You're welcome in your maths, and I got a new video on this video series. In the previous lecture we have discussed this, so now let's move to the part 3. So let's start our discussion. So in the previous video I have told you that these are the 3 conditions that when a polyhedron satisfy, then it becomes a Platonic solid, and there are total 5 Platonic solids are possible. Why only these? Today we discuss this, and how the extreme and mean ratio is a necessary component for constructing regular pentagon. We will discuss this in our upcoming video. So the condition is we need a convex polyhedron having regular polygon faces. Okay, so the first thing we need to draw a polygon, regular polygon, is our 3-sided, because 3 sides firstly need to create a closed figure. So 3-sided regular polygon, which will be our equilateral triangle, and that thing I have also written here. So the equilateral triangle is basically regular trigon, which means 3 sides, having 3 sides, so 3-sided closed figure, and all sides are equal because it is regular. Also all angles also equal. Okay, now 4-sided regular polygon. The next possibility is 4-sided regular polygon, which is our square. It is regular quadrilateral. Okay, now you might think quadrilateral, it can be regular, means it can be rhombus as well. Okay, but no, the quadrilateral is right term, regular quadrilateral, because square is the right diagram, because all the angles must be equal as well, so it must be 90 degrees. Okay, so it must be a square. Now the third possibility is our 5-sided regular polygon, and that thing we call this as pentagon, which is a 5-sided closed figure. Now you might think, what is lateral here? Lateral is also means the same, sides. As gun means the sides, lateral also means the side. Okay, here you can also call it as quad gun, but that is not much popular. You use simply quadrilateral. Now pentagon is simply 5-sided closed figure, and also it must be regular, so for that all the sides as well as angle are equal, and then it is called as regular pentagon. Now this has 180 degree total, so all divided in same equal angles. This have divided in the 4 parts, 360 degree, that is 90 degree, and the common formula to get all the interior angle sum is n-2 into 180 degree. Okay, so here when you put 4 sides, so here 4 minus 2 is 2 into 180, that is 360 degree. Here in the triangle case, when you put, you get 180 degree. In this case 5 minus 2, because they have 5 sides, so 5 minus 2 into 180 degree, that is 540 degree. Okay, now let's start from the 3-sided regular polygon, and let us see that what are the other conditions to make a polyhedron Platonic solid. So let's see. So we have made all possibilities of regular polygon faces. Now there is one more thing, is there must be 3 regular polygon faces minimum meet at each vertex, and also it is less than 360 degree, which is okay, we will check it. Okay, and minimum 3 regular polygon faces meet at each vertex must be there, having less than 360 degree. So starting from the 3-sided regular polygon, so according to the condition we minimum require 3 regular polygon faces attached to a vertex, and here that polygon is equilateral triangle, so all 3 are 60 degree and it is total 180 degree, which is less than 360 degree. Therefore tetrahedron is possible, and hence that type of polyhedron can become a Platonic solid. Now the second possibility under the 3-sided regular polygon is having the 4 equilateral triangle attached to a vertex, so 4 into 60 degree, that is 240 degree. Therefore the octahedron is also possible, because this is also less than 360 degree and following our conditions. Therefore that type of polyhedron can also become Platonic solid. And third possibility, in which we have 5 equilateral triangles attached to the vertex, that is making 300 degree, so icosahedron is also possible, and this polyhedron has 20 equilateral faces in total, means this polyhedron can also become Platonic solid. But in the sixth condition, it is exactly 360 degree, which is not less than 360 degree. Therefore, it will be a plane and can't be a polyhedron or 3D shape. Hence can't be convex polyhedron as well, so that it cannot be included in the Platonic solids. Now let's move to the second one, which is four-sided regular polygon. Now the first possibility in this, according to the condition, is having three regular polygon, which is here square. So there is all 3 into 90 degree, which is 270 degree. Therefore cube can be formed, and that type of polyhedron can become Platonic solid. And when we have four squares at the vertex, then it forms 360 degree, again a plane, which cannot become a polyhedron, moreover convex polyhedron, and therefore it is not going to be a Platonic solid. And you don't have to check up for the next, because 5 into 90 degree is always greater than 360 degree. Now let's move to the third one, where we have five-sided regular polygon. Now in this, the first possibility is having the three regular pentagon connected at the vertex. So it is 3 into 108 degree. And why 108? So here you can see that the total internal angle sum is 540 degree divided in the 5 equal parts. So when you divide it by 5, it will be 108 degree. Okay, and 3 into 108 degree is 324 degree. That is dodecahedron, which is also possible and can be a Platonic solid. And when you try to attach 4 regular pentagon at the vertex, then it will be always greater than 360 degree, and it will be not a convex polyhedron, and therefore can't be a Platonic solid. And therefore only these 5 can become Platonic solids. So I hope you get why only these. Now in the next video, this will be our target. So hopefully you get it. So don't forget to like and subscribe.